Alright, hey guys. We're going to do a little series on instructions on assembling the Daydreamer synth. So basically, we'll be showing you how to get from these two circuit boards, a few parts, some 3mm plywood like this, to the finished product here. First thing, I want to go over the circuit board. So there's two circuit boards for the Daydreamer synth. There's one that goes on the bottom, and this is where everything happens. It's one-sided for the components. On this side, it comes populated from the factory with most of the parts. The top board, where all of the knobs and switches go, and really the only thing this does is put all the knobs and switches where they're supposed to be, and then there is some connectors so that you can mount these boards something like this, and when you're playing the synth, you're interacting with all the knobs and switches here, and there's connectors going between the two boards so those knobs and switches can control all the electronics down here. I won't go into detail in this video about how everything works, but I'll just go over briefly a little bit about the architecture. This is the ATmega 328P. That's basically your Arduino Uno right here on this. The MIDI input is coming through the MIDI connector here. It's got the opto isolator. It takes in all that serial data, and this is where all the brains, all the figuring out what the switches or what certain knobs are, processes all that information, and then figures out, all it really does is take in that MIDI information, figure out what voltages to output to all the analog electronics here. This part here is your electronics, so you take in 6 volts AC, which is not very typical, but 6 volt AC converts it to a plus or minus 5 volt power supply to power all the analog and digital electronics. The ATmega over here does something pretty weird. Over here, this small guy is our TLC 5940, and that's actually typically used as a LED controller, and it's basically a pulse width modulation multiplexer. So you can take in, a few, I think it's SPI, a few SPI lines from the chip, and then it gives you like 16 PWM outputs or something with 4096, so whatever power of 2 that is, that many bits of resolution. So it's much higher than the 8-bit resolution that the Arduino typically gets. And the PWM signal basically acts as our digital signal to be translated to analog. PWM is going to be a square wave, and that's no good for as an analog signal or analog voltages. So I have these hex inverters here. It's basically a ripple reduction filter, not necessarily a low pass filter, but it's in the name. It's a ripple reduction circuit that takes in the pulse width modulated signal and converts that to a flat level. So instead of getting PWM, you get values between 0 and 5 volts, and you get an analog voltage. So effectively, these hex inverters, this TLC, makes up a pretty inexpensive digital to analog converter. It's pretty low frequency, but that's actually perfect because we don't need high frequency DACs for controlling the voltages that are going to the VCOs, VCA, and VCF of the synth. It's labeled right here. You have 16 ADC or DAC outputs here, and not all of them are used. I have pads broken out there if you want to modify it and use it, reprogram this and add some more controls if you like. You'll also notice I had extra space on the board here, so just put a bunch of holes there that should fit your standard prototyping stuff. So if you wanted to do something crazy there, go ahead. I've personally used this as I was making revisions to the synth to try new features. These are the 1, 2, 3, 4, 5, 6 VCOs. We're going to be populating these trim pots here that are for fine-tuning, calibrating the pitch of them. Then these VCOs, and there's a white noise guy right here. So that's actually a ATtiny 45 microcontroller that uses a LFSR algorithm to generate pseudo-random white noise. I use that over an analog white noise generator because this one can run at 5 volts and this whole system runs at plus or minus 5 volts. And then there are 1, 2, 3, 4, 5, 6, 7 VCAs, so 6 VCOs, 1 white noise, each of them gets their own VCA. They all feed into the a mixer right here. It's a very simple mixer, op-amp mixer, and that feeds into our diode ladder filter over here. So that's your VCF, and that goes into our PT2399 delay. So that's our delay circuit right there, and then all that feeds into a final amplifier and output to your line audio.